Hello students, in this today's video we're going to see a proof, and I'm going to prove that root 3 is irrational. So let us go to the proof. So before going into the proof, we will see some definitions. Okay, so the first thing is, what is rational number? So rational number is something which can be expressed in the form of p by q. So I'll write a number that can be expressed in the form of p by q, where p and q are integers. Okay, so we all know what are integers. So, and also this p and q are co-prime. Okay, so this is the actual definition of what is rational number. So let us see some examples. What are rational numbers? So if I take 2 by 7, so is this fraction follows all these what I said it? So see, 2 and 7 both are integers, and also they are co-prime. And what is this co-prime? Co-prime means when the two numbers don't have any common factor between them. Okay, so we say that they are co-prime. Got it? So we can even take negative numbers as well. Why? Because these are integers. So integers have positive, negative, and even 0. 0 is also a rational number, because I can write 0 by 1. And the main thing is, one more important part of this rational number is this denominator q. This should not be 0. Okay, because we know anything uh, by 0 is actually what? Undefined. Okay, so anything by 0 is called undefined. We don't know what is this value actually, but if the numerator is 0 and the denominator is anything else, so we can say that this is actually 0, and 0 is a rational number. Okay, so we need to take care of these terms. One is p and q are integers, and then q should not be 0, and also p and q are what? Co-prime. Got it? So co-prime. Next, let us go to the question of the day. So I wanted to prove that root 3 is irrational. So this is the question for us. We need to prove that root 3 is irrational. So how we can do this? So we are going to use a contrapositive proof for this. Okay, so we are going against what the question is asked. So they are asking, is this a rational number? We need to prove that, we need to prove that this is an irrational number. Okay, this is irrational number. So I'll take that, let this root 3 be rational. Okay, so this is the way we are going to prove this. Okay, so let root 3 be rational. Okay, so I'm taking the opposite of that. What the question is asking, we need to prove that it is irrational, but I am taking it what? Rational. We are going in a contrapositive way. So any number which is rational can be expressed as what? P by Q. So I'm writing this root 3 is equal to some P by Q. Okay, so now the next step which we are going to do is, we need to do squaring on both sides. Squaring on both sides. Okay, so what happens after this? This root 3 whole square, and the other side is p by q whole square. Okay, so root 3 whole square is what? 3. and here it is p square q square. Next is you need to shift this q square there and 3 to the down of p square. So we need to do this. So why we are doing this? What is the reason behind this and what we get after this? So there is a statement uh, which we can prove it in some other video, but in this video I'll give the statement that whenever p square is divided by 3, okay, then, or you can write whenever wait, you can write this something else like whenever 3 divides p square, 3 also divides p. Okay, this is a statement and it's true always. So if you want to see, I'll give a small example. See, if we say that 3 divides 3 divides uh, and let us take like 6 square. Okay, I'm taking this is p square. Okay, so we know what 6 square is, what 36. So 3 actually divides 36, isn't it? 3 divides 36 and we get 12. So is this 3 divides the number, the only number without square? Yes, see, it divides. So we get here 2. So this example which I gave, this is always true actually. Okay, you can take any numbers, okay, it will follow. So whenever 3 divides p square, 3 also divides p. So this is something unique which we have noticed here. Okay, so next is, so what does this mean? So this means that this p is some multiple of 3, isn't it? This 6 was multiple of 3. 6 square, that is 36, is also multiple of 3. Okay, so therefore I can take, let this p is equal to some 3c, or you can take 3k, whatever letter you like. So now we go to the last part which we left there, that is q square is equal to p square by 3. Now you substitute, okay, you substitute this part. So q square is equal to 3c whole square by 3. So next is, this becomes 9c square by 3 and this is q square. Okay, so I'm just putting p as 3c and then the square I'm taking, which we get that 3 square is 9 and c square is c. Is this cancelling? Yes, we can cancel it. So now what we have q square is equal to 3c square. Now do one more thing. Now drop this 3 to the left hand side, that is by q square. Okay, q square by 3. Now you again notice that 3 divides what? Q square, which means what? That this 3 is also dividing q. So when 3 divides q square, then 3 divides q as well. Okay, so you can write here. Okay, here 3 divides q square, that means 3 divides q. Okay, so if you go back and see what we have done till here is one equation which I can mark this part as equation 1, and again here if I mark this equation 2, we have seen that 3 divides both P and Q. Okay, I can write this by equation 1 and 2. Okay, so I can see that 3 divides both P and Q. Okay, so which means they have common factor. Common factor as 3 other than 1. So which is a contradiction. Okay, which is a contradiction. So we arrived to a contradiction. This means what? We said that the given number is rational, and when we are taking it as rational, we are seeing that P and Q, they have some common factor, and the definition of rational number, it says that there is a co-prime relation between P and Q. But here we can see that there is no co-prime relation. Hence we can say that root 3 is what? It is irrational. Instead of saying that it is rational, now we can say that it is rational, irrational. Okay, see, by 1 and 2 we got that there is a common factor other than 1. That is, common factor is what? 3, which is a contradiction. Contradiction means which we are going against what we have taken. Okay, so hence I'll write here that hence uh, root 3 is an irrational number. Okay, so with this small proof we are going to end today's session, but we have very important means proof. This is a very important proof, so you should go through that number of times so that it will be easy for you. Okay, thank you so much for watching. Have a good day.